Yeah.
Cool. I was saying previously we were talking about the CLI southbound plugin and session with iOS, and today we can take a look at how to extend the functionality. And here we will be implementing a unit that will give us neighbors and their advertised routes. So just a quick recap from the previous session. We're talking about the CLI. So OpenData like to manage CLI only devices. Architecture and the framework, and we were also talking about how the framework is trying to be as generic as possible, but the actual translation between the model and the CLI commands needs encapsulated in what we call a plugin. That needs to be the type or device type family, right? So those boxes right here. And we our what we begin. We are a single transition plugin into multiple units. Atomic self-contained unit of the end data handlers, right? And this allows the framework and faster development of the units. And each unit usually is on smaller aspect of management of a single type, like in this diagram, we can see iOS interface management unit, so on and so on. So today we'll develop, an iOS sample unit that will focus on the BGP neighbors management. Okay. So the FRINX web. This is the user guide, and we also right here basically go through the developer our unit archetype and running open and check okay, so let's I'm running and I have installed the CLI all units that come with FRINX open. So what we want to do now is to generate a new sample unit, running OpenData and test it out. So what we need to involve Maven archetype generate command pointing that to our archetype. So like this, and let me just quickly exit directory, like which device type we want to say. Let's do things like this is just a group. It doesn't really matter. Let's call it sample, but this will be like routing something on the line. Package for the unit and say. Okay, so these are and with the sample available right here. It's basically source files, some XML control, right? We could build that right away, right? This is install plus some plus to just keep the test doc and all that to make it quicker, right? It's successful, and with the target folder, the jar file right here. This jar directly install that into our running OpenData. Let's install that with install command, right? That's our jar. It's active, right? So what we will do, we will go into OpenData and through REST-conf ask what the available units are currently loaded. Right? As in session, right, query our registry for CLI. Right? So let's do that. type, we should see our sample IOS, and we can see that. Right? Our sample is a single Yang model, because it's sample that was generated by the archetype. It registers two handlers, a reader for this sample instance, and another for the same. No, right? And it is, right? Doesn't make much sense. But what the unit actually does, it lists the RFs from the device and in the structure. So we can check it out by mounting an iOS device for lab, right? But to that, wait fully over on this one. Right, it will get there eventually. Okay, right. So with an active connection to a node called iOS1, and these are the Yang models that are implemented. We're able to see our sample Yang model in there as well. Right. This is one that was provided by the unit, and it's ready for use. Right. So
okay.
Pull all the data from iOS1. Also contain our sample flight data. Right. So which thing data that we are parsing in older units, but let's forward the sample one. Yeah, right. It's a list of instances. Item is basically right. We can see the RF. We can verify that by the device. So let's send that to one. Right. So if additional like 99. Let's see that appear right here. So let's send the request, get data, and yeah, we can both the instance here, right? So already that was deployed into running OpenDL and some information, right? And that gives you. What I can do now is investigate what the archetype generated. Inject into IDE. Sample 6. Okay. Okay. It's a stable project. Very simple. You have this main folder and your POM, right? To do all the dependencies on the iOS, on the FRINX, plus all the other old stuff. And then main, you have your XML configuration, basically just the rest of OpenDaylight and the framework. You have Java classes. The unit that reads into the framework, therefore the instance we were invoking was this reader. But let's examine the Yang model first, right? So before something like sample/instance, that's right here. We have contains only single list called instance, basically has two attributes, ID and the unit currently parses just the ID. So this it was by archetype.
Okay.
So what all does with this model is that it generates just for each node if we open the target and examine the classes generated sources folder and the binding folder, we can see each of the classes right here. All of these were generated by OpenDaylight, and what OpenDaylight is binding aware data or binding aware, right? So it generates Java classes for you. So we fill them in, read the your type, right? You can see the sample instance there, and that's one of the effects that we build on, right? If you're saying OpenDaylight generates the classes for you, your handlers, it's easy for you to implement the because type safe classes that you already read from, right? So that aspect, and what OpenDaylight does, and most of the APIs work upon. Okay, so I can get to the code.
Okay.
Let's open the unit. Let's open the unit class. Right. So it's a class that implements our translate unit interface. And what it tells the framework device type, it supports, right? It raised itself into the framework. These methods are the most interesting part, right? It tells you which Yang models it implements. In case it implements just a single Yang, it's present in the Yang folder, right? It can RPC handlers. So if you have a model, you could buy the handler. In this case, we don't have any RPCs, so that's empty. And the last is provisioning of data. You need to pay your readers and or right managing a single node from the model. Right? So, for example, here we're adding a list reader for instance, right? And all over right node, and these two are classes that we actually implement in the unit. In this case, they work, right? So you need to register handle for read operation, update, and delete operations into the frame, right? So that tells the rest of the framework which models implement and which nodes out of the index register, right? And that's all. This is a unit, right? Any so far, or can we jump to the handlers?
Is this was printed by the Maven called it, and does it ever change? I didn't hear changes depending on circumstance.
Yeah. These to change. If you were to add additional nodes, it change basically these methods later on.
Okay.
Right. And we have two handlers. We have the interface writer and interface reader. We exploit the read operation and all other write, date, and delete. Only the read part if you in the configuration, right? We can quickly open the writer. This is a very simple writer. It basically executes configuration for iOS. You type into that, right? And that's all. You do any checking at the moment. Very simple. But it the operation and delete the operation. So this is pretty straightforward, right? Deleting the RF, and setting just the description at the moment. This word.
Yep.
There is a bit more interesting, but what's right? So this is a list of in this, which translates in RF or IPVRF command. So what it basically invokes a show IPVRF and then parses all the IPVRFs, right? Using some
Okay.
Right, basically. That's pretty straightforward.
Okay.
So we can move on and add something more interesting into this. Let's open the game model, right? And let's start with our native. So let me call for beavers. We will have a top level neighbors, and in that a list of neighbors, basically.
Okay.
That's standard modeling technique. What you're interested in is basically the ID of neighbor, which will basically be an IP address. Right? Let's keep that as like string info, and let's also right? We can also just time being out like type, right? But to keep it simple, I think everything as string.
Gotcha.
Usually require an ID to be, so let's like our key, right?
Okay.
And what we all can do that contact list, right? And what is the network and connect.
And cover both receives and advertised prefixes, or would you need to create those separately if you heard about both of them?
We could fill both of them, but it wouldn't be very right. So
Okay.
maybe we would do some another length that would tell us right where they
I
come
see.
from. Define something
Right.
like here.
Okay.
Right?
Okay.
Usually you don't that kind of model. There are standard models like IETF and OpenConfig, and they already cover everything you need, or at least most of the stuff. You rarely find something like this. But so you definitely can. But we are doing for our distribution is OpenConfig EA model, right? That's the standard. We implement that for each device. We actually use this kind of model, but BGP and OpenConfig models. We actually, it takes time. Okay,
right.
we'll define the key for this, right? Of our EA model. We will also have, right? So let's re-invoke Mail because of the class happens when on compilation. So let's go. We could do that from the command line, so possible from the ID. The build succeeded, and we should see signal in our generate source. And we do have the APIs job, and we can go on and implement the handlers. Okay. And can start in the readers method. So we want to provide another reader, right? Follow our Yang model. The top level neighbors, right? There's a case in this framework if there is a container that doesn't have any leaves, just like children, you can use the structural window, we call that. Basically fills in the gap in the hierarchy, but you don't need to implement any, right? So just register that. You can use the class, right? Already class. Let's your class, and that's it. We have the top level. To mention here is the inside that. And that's also the concept, and it's a path model, right, from the top, right? Each handler in our framework needs to be registered under a certain path, so they can identify which type of data it handles. Because you can have identity for different nodes at these levels, so we need where we want to handle the data. Right. Okay. So now let's think like reader, right? Path starting from top, but now handling the maybe if we go back to the model that we want to handle. Okay.
Got it.
If you do that, instantiate a generic reader, put path, and put your own handler into that. So let's let and CLI. The C object encapsulates slide session, enables to invoke any command and get the reply. So data class for this. It needs to implement CLI, it's a generic, and like which class and right, but it gives you the time that's very nice later on, right? So if you put up with that, you get the type safety node. You could skip that, right, and make that unchecked or install class in Groovy and don't care, right? Close the type safe. And the type safe is actually really nice. Oh, okay. Are most interesting. Like get all ID. You need to part the neighbor list from the device and return as neighbor key, framework. And then return attributes for each neighbor key. You can read additional data like the number, whatever. There's two methods. That's a boilerplate that you need to fill in. I will try to get rid of that, but currently the framework can't do that for you. Right? So you new instance of your builder class. You need to implement merge. And that's basically telling the framework to put the data into the hierarchy of the nodes from Yang. It's also pretty straightforward. It's so annoying. It's better to get rid of that. But for now, keep it safe. Okay, we do a boilerplate, right? And let's get CLI reader, we can invoke, right, using method. So invoke BGP neighbor on the it's long because it has some error and application background and right. So you can invoke that, and we have output of invoking and on right. Somehow, right? If we go to files invoke manually, a lot of output, right? But what I'm interested in is this ID, right? Okay. I don't care about much more. There should be should be 3 neighbors on this device, right? Can use with some utility methods, parse the output. You could do that, however you would like, but with utility methods, parse speeds, right? We don't want to keep anything, and we need a regular expression, right? So let's the regulation from my previous effort, just to make sure that I get that. Okay. So the regular expression, my BGP neighbor is and interested in, right? So let's check forward. So okay. I but it's basically going just make sure we okay. Next thing we need to extract. So we are interested in the I group from our regex, right? Last thing is transfer function, right? So we want our string into the neighbor. Right. So that's that. Oh, okay. It for this method. We are already parsing the IDs of all the BGP on the device. So if we check the model, at the AS number, right? That's in our last test as well, and happens different attributes, right? So IDs just parse the time, and here's the rest, right? So we will okay. I will pull the regex from previous session. Okay, this. And again, utility method to see. Right, so okay. Give it boot. Again, we just want to match the regular expression. And we are interested in the ASM, and it will just set the ASM.
Okay.
This is that involves the same command. It actually goes to the device throughout a single transition and the output of show IPBGP neighbor. So we can invoke the read here, but it's really, immediately we are performing the read just once.
Okay.
We are doing here using this regular expression to set the AS number into this field, right? And
ID to AS in line 52.
no, I think it would be the same. Yeah, but it doesn't matter whether it's AS or I.
Oh,
But
okay.
thanks for okay. One more thing we need to do is set the actual ID. We don't get output because it's already provided here.
Mm-hmm.
Okay, fine. And now we should be setting all the AS and the ID. We can check the bill if there are any other fields, right? And we can see that there are the pieces, but we won't work with them for. We have set our ID and AS. The key is set automatically because the key, right? We should be covered and ready to out. Okay, so let me load this. And in the meantime, also rebuild our units. Down here, I'm
Right.
calling the sample unit, right?
Mm-hmm.
So let's give this a couple. Okay. All sample unit. Okay. Right, and we will check our registry if we have the unit there. But this, this entry has appeared, and it's basically saying that we have a new place, right? And we should be able to. Right, so let's mount the tiles again. Give it a couple, and we'll again involve data and see if you have, the neighbor available. Okay, this is the result. See, this is container, and we have 3 neighbors from the same.
Nice.
We can
Mm-hmm.
we can what has happened. So if we turn on the logs, turn on the trace, right? Okay, but we will not be reading the entire data. We can invoke, just our next. Okay, and we can see the output of daylight. This is the output that we parsed, and check which which was executed.
Okay.
The log. We can check that in journal. Right? So if all the commands that have been on the device can be that at this time we have execute IPv6 neighbor.
Mm-hmm.
We have, right? So with the neighbor list, and what's left is to implement the prefix. Right? Send it back to our IDE, and we get back to the unit and repeat, the process once again. So we want to register for the prefix container. Could do that. just a note, it's like that wrong path, right? Like
Okay.
if I were to add neighbor again here, right? It's that neighbor is not a child pre-existing, it's all wrong, right? But the other, and it's let's different. And that's the type I was mentioning, right? You shouldn't be able to contact wrong handlers and put them in wrong place. Okay, so you
Tell you that you're doing it wrong.
yeah, exactly. And then when you are in reader or the writer, allow you to set something wrong or something of wrong type, right? Okay. Add again reader. Okay. Create a class. Again, we need reader or a prefix. Simply we need to specify key and it's good. Okay. For play. Yeah. Set all the IDs, right? In this case, the ID will be let's check device. So let's examine for this neighbor.
Mm-hmm.
This will be currently the single. So we will take this as our next hop, right? If we consult our model from 4, it should fit network and all. Again, these are just strings, but it's something more per string. Let me feeling from my previous one. While we have time. And 60. So again, this one is more specific. We have a registration, and we are doing the same thing, matter, but now we are taking two fields instead of one and creating the key. But it's basically the same, right? For read current attributes, so let's fill those 2 items as well. Read anything from the device because both the network and the host are part of the key model here. And key, we don't need to read again. It's provided in the ID here, first key of it. Okay, right? We do have the prefix registered properly. So once again, we need to rebuild it right? Because we have modified code. And we will inflow the quantity change.
Absolute requirement that you need to reload light when you add something like this?
No, it's seen before, right? When you add new mods, right, it works fine. Modifying an existing one, and we have an active connection classes, right? There might we test it out, but it should do that unit,
Okay.
right? I just know
I'm just
get
curious.
into issues right now.
Okay.
So that's our goal actually. If you're adding new unit, you can do that at any time, right? But in an existing unit, there's still some work to do.
I see.
So yeah. Now it's actually adding the unit into running, open the CI topology just fine with a couple and a brand new unit.
Mm-hmm.
I think to refresh the same, but yeah, almost if we had a active connection.
I see.
Okay. So again, in the meantime, we check the registry. So this was our previous state, and now we have the prefix handles. So you can see what implemented from the model, what read, and what model. This is nice to see.
Yeah.
What we can use. Especially if you have bigger models like the OpenConfig or something similar, because they cover what you can't fast as you would like. Again. So those are our previous right? Under some of these neighbors. So let's send it. And this is our output now, right? Right? Number has advertised some prefixes. And this is the output. Right? And it's already working. Here we are pulling all the configuration, but we can limit that just to the neighbor. Also, query just this, right? This one. Just get the prefixes.
Yep.
And Yang and the rest of, and to have that you can do all sorts of interesting data, model, and you have the model, right? Power.
Yes. That.
So these just the readers, right? But we can do the same for writers as well. But to implement both at the same time, if you're interested in reading the data and parsing the data, maybe perform some, on top of it, you can do this. That's very quick.
Okay.
At the later point, all the CRUD operations create read, update, and delete the handlers. That's also very powerful. That gives you functionality, that gives you rollbacks, that gives you regulation, and all that, right? Framework can do for you. You provide handlers with all the. Yeah,
cool.
basically it's prepared for today.
Okay.
We can maybe on or dive a little deeper next time.
Okay. It was an excellent demonstration. I really appreciate it. So, you to work all that code the first time.
In the handlers,
Yeah.
now. Right. The most difficult part is identify the command that you need to invoke and the expressions, right? And the mapping between the data from EA and the output of the commands, right? I think that's the critical part. Implementing that with Java or in Ruby or whatever else, I think that's pretty straightforward. The problem is, identifying the EA model and commands on the device. In very simple EA model, right? So it was to take something like OpenConfig, right? So it's time to develop that. But one that it's pretty straightforward. It's just writing Java code, regular expressions, and that's all.
Love the opening code you might use.
Yeah. Check OpenConfig for BGP and find the neighbor list and the list. So let's be on the BGP model. Right. And if you check 8 OpenConfig models, right?
Mm-hmm.
But I think this is the one. Yeah. So BGP. So then we need to find, the groupings and all. They are modular, the models, right? So we have neighbor list and the list of neighbors, but we don't see the actual configuration in here, right? So we need to do the groupings, config and some state, right? Again, so let's find this one. Yeah, interesting, like enable or peer group. All of them, but they are a little bit. You can also check because that's the one that contains the fixes and let's just search for. So we have a route and we need actual data in this model origin, right? And all the others. So yeah, so it's to our simple model, right? But you don't have to implement everything with this framework, right? You can just pick which nodes are of interest and continue.
Okay.
We start with a very simple EA model, try to fit it into that, implement that with real models. In this case, we actually want to go with for all these types. So yeah, we are on OpenFix support for various deals.
I see. And that's IETF model?
No, that's not actually. That IETF, that's Google, I think.
Okay.
And we have experience in implementing IETF as well as and we decided because they are easier to implement. More, we don't need any modifications to them. So they are like this compared to IETF.
Okay. Appreciate the demonstration. I'll be it over again, and I'm sure other people will here too. To get us goes on under the covers when you're implementing a new piece of functionality, a new unit. I really great time in getting this set up for us.
Sure. No, I was feeling bit of boilerplate code, along the way. We would like to read of that, but in the meantime, just, do that one implementation.
Right.
Also, send to you probably.
Okay. That would be cool.
Yeah. Sure.
All right. I can test on my own network.
Yeah.
Exactly.
Yeah.
Okay.
And if you have any questions,
Thank you.
writers, because that's a little different, right, from the readers, then I don't know with you. Or then I'll check out the other guy. Perhaps it has some documentation on that.
I'll do some questions that I have.
Cool. One last thing that I have. I can use some links about the Open Daylight generates, code from Yang, documentation on response, how the sync to JSON. So a couple of things. You really need to know your Yang. You need to know Open Daylight Yang, and the thing design framework. I think that's the simplest part.
Okay.
Also say,
Yeah.
sorry about that.
Go ahead.
Peter, I should also say, certainly, so I think we've created it with accessible for everybody in mind, so that if you want to build a new structure, you can do that at any time yourself. But of course, if there is happy to, and we'd be able to implement these as well. If we come to, if we work it, we'd be as well.
Okay. Yeah, kind of what I wanted to get a sense of is where the line would be between we can help and we need help. It would be best if we add to it. So much appreciated. Thank you. I know it's a little late your time.
It's still good. It's afternoon. It's no problem at all.
Okay. Well, thanks again. I have to jump off, but look for the and I will get back to you with more questions.
Okay.
Okay.
Take care.
You too.
Goodbye.
Bye. Thanks, Maris. Bye.
Thank you.